We're all living through the AI revolution, right? It's happening all around us. But today, we're not going to talk about the software or the fancy new algorithms. Nope. We're going to pull back the curtain and look at the massive, hidden industrial gear that's actually making it all possible. The real physical foundation of our digital world. So let's just jump right in with a huge question. With all this incredible momentum, what's the one thing, the single biggest roadblock that could actually bring the entire AI boom to a screeching halt? Is it a lack of brainpower, a shortage of GPUs? What do you think? Well, the answer is surprisingly simple, and it's probably just a few feet away from you right now. It's not the software. It's the socket, the actual physical plug in the wall. You heard me right. The ability to get enough clean, reliable electricity is now the #1 bottleneck for scaling AI. Okay, so let's really dig into this. Why on earth is our traditional power grid, this thing we rely on every single day, suddenly becoming the biggest hurdle for AI's explosive growth? See, the problem isn't just that AI uses a ton of power, which it does, it's the way it uses it. When you're training a massive AI model, you get these huge, sudden power spikes from all those GPUs firing at once. And our aging grids, they were just never, ever built for that kind of volatility. On top of that, getting grid upgrades approved can take years. We've got extreme weather knocking things out more often, and even a tiny flicker from the grid, what engineers call dirty power, can literally fry millions of dollars worth of servers in an instant. So how do you power the future when the old system just can't keep up? Well, the answer is a really elegant solution that's becoming the hero of this whole story, the microgrid. The simplest way to think about it, it's like having a private, personal power plant built specifically for your data center. But a microgrid is so much more than just a backup generator. You have to think of it as its own little intelligent energy ecosystem. It can generate power right there on site, maybe from solar or natural gas. It can store that power in huge batteries, and it uses smart software to manage everything, allowing it to run completely on its own, totally separate from the main grid if it has to. This is a total fundamental shift in strategy. The old way was completely reactive, right? You had a big diesel generator just sitting there, collecting dust, costing you money, basically acting like an insurance policy you hoped you'd never use. The new way, the microgrid, is proactive. It's working every single day right alongside the grid. It's using a mix of energy sources to save money, and it can even make money by selling extra power back to the utility. It turns energy from a boring cost into a real strategic asset. So let's pop the hood and see how this all comes together. We're going to look at the anatomy of a microgrid during a real crisis, and you'll see how it conducts this perfect symphony of uninterrupted uptime. All right, you've got 4 key players in our orchestra here. You have your on-site generation, the instruments making the power. You have massive batteries for energy storage and, crucially, for speed. You've got the intelligent software controller, that's the conductor. And then you have the most critical ability of all, islanding, which is just a cool way of saying it can completely and safely disconnect from the main grid. Okay, picture this. The main utility grid just went down. A whole city is blacked out. For a multi-billion-dollar AI data center, this is a code red, DEFON 1, all-hands-on-deck kind of emergency. This is disaster territory. But before the servers even have a chance to notice, before they can even blink, the microgrid's battery system kicks in. And we're not talking seconds here. We're talking milliseconds. It creates an instantaneous bridge of clean power that guarantees the computers never, ever miss a beat. That kind of speed is something a clunky old generator could only dream of. This whole switch to what they call island mode is this flawless, beautiful automated dance. First, the battery creates that instant power bridge. While that's happening, any on-site solar or wind just keeps on chugging, feeding the local system. Then, the heavy-duty gas generators get the signal to fire up, ready to provide the serious sustained power you'd need for a really long outage. So, who's actually building these incredibly complex power systems? Well, the names behind this revolution are probably not the tech companies you're thinking of. They're some of the biggest, most established industrial giants on the planet. You can really break it down to 3 key architects: Schneider Electric, Eaton, and Caterpillar. Think of Schneider as the digital brain, providing the smart software that runs the whole show. Eaton is the grid-to-chip protector, managing power quality for everything from the main connection down to the individual server. And Caterpillar, they've become the primary power provider, supplying the massive gas turbines that can run these places 24/7. Now, this technical pivot from just selling backup gear to providing primary essential infrastructure is creating just enormous financial value. So let's follow the money and see who's really winning the AI gold rush by selling the picks and shovels. And let's put a spotlight on Caterpillar for a second.
And when most people think about Caterpillar, they think about something very different. Big yellow machines that do the hard work of building the world's infrastructure. So, to me, I think it's a fair question. Why are the big yellow machines here with the tech heavyweights? And the short answer is this. The digital world depends on a physical layer most people never think about. Every device in this room that you have depends on minerals that had to be pulled from the ground. Every data center behind the AI you're going to see this week, or you're going to hear about this week, was constructed from the ground up, and it stays online with power systems that provide reliable electricity. Every road, every port, every power line connecting our economy had to be built. That's the invisible layer of the tech stack, the physical foundation for modern technology. And that, it doesn't happen without Caterpillar.
They are now a central player in high-tech computing. You see, data centers are facing multi-year waits to get hooked up to the utility, so they're just going straight to Caterpillar and saying, build us our own power plant, right now. And the scale of this is just staggering. In the fourth quarter of 2025 alone, Caterpillar hit record sales of $19.1 billion. Let that sink in. And a huge driver of that growth was data centers buying their massive gas turbines to power the AI boom. And Wall Street? Oh, they noticed. Big time. In just 1 year, from February 2025 to February 2026, Caterpillar's stock more than doubled. That incredible surge wasn't because of a construction boom. It was the market waking up to the fact that Cat had become a primary power play for artificial intelligence. Now, while Caterpillar's run was just wild, they weren't the only ones. Schneider Electric and Eaton also saw fantastic growth. Schneider is cashing in on its software and its cutting-edge liquid cooling solutions. And get this, to really understand the demand, Eaton is currently sitting on a record electrical backlog of nearly $20 billion. They can't make this stuff fast enough. And don't for a second think these are just dusty old industrial companies rebranding old tech. They're actively innovating for this new world. Caterpillar launched new gas generators that start up faster, specifically for this primary power role. Schneider is now using AI to predict and prevent power spikes, and Eaton developed a whole new, super efficient power supply to handle the unique demands of AI chips. They are literally building the future piece by piece. So, what's the big takeaway from all this? It's that the AI race is now just as much about megawatts as it is about microchips. These industrial giants have completely transformed from being simple backup vendors into essential infrastructure partners. By creating power on-site, they let AI companies skip the line and deploy years faster than the public grid would allow. They are, without a doubt, the modern-day suppliers of the picks and shovels for this incredible digital gold rush. Which really brings us to a critical conclusion. The ultimate winners in this new AI era, they might not be the companies with the cleverest code, but the ones who can guarantee, no matter what, that the lights stay on.